The deeper we look into reality, the more it begins to slip away from us. The solid world we think we know, the world of objects, shapes, distances, and certainty, slowly dissolves like mist under gentle morning light. And beneath it, hidden in a place that feels both impossibly small and infinitely mysterious, lies a quantum world that seems to follow no rules we were ever taught. Scientists call it the foundation of everything. But it behaves like something that shouldn't exist at all. Tonight, we drift not through galaxies or distant nebulae, but through the strange and quiet machinery beneath reality itself. A realm so subtle, so delicate, that even the act of observing it changes what it is. A realm that unsettles even the brightest physicists. A realm that feels more like a dream than like the universe we know. A realm where certainty disappears and possibility becomes the only truth. Beneath everything we touch, everything we see, everything we believe is real, lies a shimmering uncertainty. Particles flicker in and out of being as if reality is breathing, forming, dissolving, forming again. Scientists once thought they could predict everything, where objects were, how they moved, what forces guided them. But in the quantum world, that certainty melts away. Particles do not move from one place to another. They exist in many places at once, spread out like soft ripples in a pond. Not here, not there, but everywhere their possibility allows. As we drift deeper, the air around us feels soft and still, like entering a quiet forest where each leaf is made of probability. Nothing is rigid. Everything vibrates with hidden potential. You reach out to touch something, and it slips away like mist, reshaping itself as your attention moves. Observation doesn't just reveal reality. Observation changes reality. Physicists found that when you look at a particle, it chooses a position. When you look away, it spreads into a cloud of possibilities again, as though the universe responds to your attention. Not with certainty, but with a whisper. The quietest place in the universe is not deep space. It is the quantum realm, a place so small that distance loses meaning, so delicate that measurement becomes disturbance, so strange that cause and effect begin to blur. Particles can become connected, deeply, instantly, across any distance. You change one here, and the other reacts there. Einstein called it spooky action at a distance. He was unsettled by it. All scientists were. But experiment after experiment proved the same quiet truth. The universe is not separated. It is entangled, and beneath its surface lies a trembling world. A world built not on certainty, but on questions, on possibilities, on gentle, shifting probabilities. And tonight, we drift into it, slowly, softly, letting the boundaries of the ordinary dissolve as the quantum world opens like a silent door. As we drift further into the quantum realm, something unexpected begins to unfold. Not a discovery, not a revelation, but a quiet contradiction, one that sits at the very heart of reality. The deeper physicists look, the more they realize that the rules that govern the quantum world do not match the rules we experience in everyday life. It is as if the universe speaks two different languages at once, one calm and predictable for the macroscopic world, and one soft, fluid, and deeply mysterious beneath it. And the bridge between these two worlds is fragile, shifting, almost dreamlike. We move deeper now into the strange zone where particles stop behaving like particles altogether. They stretch into waves, not waves in space, but waves of possibility. Ripples not of water or air, but of everything that could potentially exist. It is not that the particle becomes uncertain. It is that certainty itself stops existing. You can almost feel it in the air. a soft vibration, a trembling of reality that is too subtle to touch, yet too fundamental to ignore. Every atom in your body carries this trembling. Every electron around every star carries it. Everything that exists is built from this same quiet shimmer. And scientists realized something chilling. Nothing in the quantum world settles into being until it must. A particle does not choose a position, a path, a momentum, until the universe demands it, until an observation nudges it gently into a single outcome. Before that moment, the particle lives in a haze of possibilities. Not one, not two, but all of them. Superposition. A word soft enough to whisper, yet powerful enough to overturn our understanding of existence. We drift through this shimmering haze now, through a landscape where particles overlap with themselves, where futures fold and unfold like silk. The quantum world feels like a dream trying to make up its mind. And yet, this is not imagination. This is not poetry. This is not metaphor. This is experiment. Physicists performed what is now one of the most famous tests in the history of science, the double-slit experiment. A particle, an electron, a photon, even an entire atom, is fired toward a barrier with two narrow slits. Behind that barrier lies a screen that records where the particle lands. Fire one particle, it lands somewhere. Fire another, it lands somewhere else. But fire thousands, and something impossible happens. The particles form a pattern not of two clusters, which would make sense, but of many bright and dark bands. An interference pattern, the kind formed by waves, not particles. As if each particle went through both slits at once, interfered with itself, and then landed in a place dictated not by certainty, but by possibility. Scientists stared at the results for decades. The universe was speaking a language no one understood. To test it further, they placed detectors at the slits, tiny instruments designed to watch the particles, to see which slit they passed through. And then something happened that defies logic. When watched, the particle behaved like a particle. When unwatched, it behaved like a wave. Observation changed reality. Attention shaped existence. Awareness collapsed possibility into a single outcome. One physicist said quietly, "It is as if the universe refuses to reveal itself until we look at it." Another whispered, "And when we stop looking, it returns to being everything at once." This subtle, silent dance between the observer and the observed continues no matter how far we drift. It is the heartbeat of the quantum realm, the soft pulse that underlies every physical law we know. But the mystery does not end there. As we drift deeper, we encounter something even more haunting: quantum tunneling. The idea that a particle can pass through a barrier it should never be able to cross. A wall, a boundary, an impossible obstacle. And yet, the particle slips through effortlessly, as though the universe gives it permission simply because it might be possible in some tiny fraction of its wave-like existence. Stars rely on this phenomenon. Fusion inside the sun depends on tunneling. Life depends on fusion. You depend on life. Which means quantum tunneling is not a rare quirk. It is the reason the universe shines at all. It is the soft, improbable miracle woven into every ray of sunlight that has ever touched your skin. We drift past this realization slowly, letting the magnitude of it settle like dust on calm water. Nothing in the quantum world obeys the rigid expectations of classical logic. Everything stretches, blends, overlaps, dissolves, reappears. Reality behaves like a liquid, not fixed, not definite, not certain. And as we move deeper, we encounter one of the most unsettling ideas yet. Quantum randomness. Not randomness because we do not know the variables. Not randomness because of incomplete information. But pure randomness. As if the universe sometimes rolls a cosmic dice and chooses an outcome with no underlying cause. Physicists resisted this idea. They searched for hidden laws, hidden mechanisms, hidden structures beneath the uncertainty. But after a century of experiments, the quiet truth remains. Some events have no cause. They simply happen. Unforced, unpredictable, unprovoked. A particle decays not because something triggers the decay, but because the universe chooses that moment. For no reason at all. This is the quantum world, a place where the foundations of reality feel more like soft waves than solid ground. A place where cause and effect unravel into gentle uncertainty. A place where the universe reveals both its vulnerability and its strangeness. And yet, in all this strangeness, there is something peaceful, something soothing, something strangely beautiful. Because as we drift through these quiet probabilities, a new perspective emerges. Reality is not a machine. Reality is not rigid. Reality is not cold. It is flexible. It is fluid. It is alive in its own mysterious way. The quantum world is not terrifying because it is chaotic. It is terrifying because it is free. Free from our expectations. Free from our definitions. Free from the rules we try to impose on it. And yet, this is the world beneath everything. This is the world that builds the stars, the atoms, the galaxies, the cells, the thoughts, the dreams. This is the foundation of existence. Soft, uncertain, quiet, endlessly mysterious. And tonight, we drift even deeper into this trembling reality, letting its strange logic wrap around us like a slow, calming fog. As we drift deeper into the quantum realm, the familiar structure of reality continues to dissolve around us. The world we know, solid, steady, predictable, feels like a thin surface stretched over something far softer and far more mysterious. Beneath that surface, the rules shift again. They become quieter, stranger, and somehow even more dreamlike. We now approach one of the most unsettling concepts in all of physics. The idea that particles do not simply exist in space, but that space itself may not be what it seems. For centuries, scientists imagined space as a stage, silent, unmoving, unchanging, where matter and energy dance their cosmic dance. But here, in the quantum foundation beneath everything, the stage wavers. It flickers. It hums softly with a kind of energy that cannot be seen, but can be felt in the most delicate ways. Quantum vacuum energy. The name sounds empty, but the vacuum is anything but empty. Instead, it is filled with fields. Gentle, all-pervading fields that ripple even when nothing is there. These ripples come from particles that do not exist, and yet do. Virtual particles, physicists call them, ghost-like fluctuations that appear and vanish faster than any instrument can measure. They are not illusions. They are not mistakes in the equations. They are not metaphors. They are real enough to tug on the universe. In the soft darkness of the quantum realm, we feel the vacuum subtly vibrating. Not loudly, not violently, but with a faint, trembling hum, like the sound of distant waves under a quiet night sky. This hum has consequences. It curves space. It affects time. It nudges particles. It shapes the universe itself. And here comes the part that unsettles physicists most. These fluctuations happen everywhere. Always. Even now. Even around you. Every cubic centimeter of empty space is alive with virtual particles flickering in and out of existence, borrowing energy from the vacuum itself, leaving faint echoes as they appear and disappear. It is as if the universe cannot remain still, as if reality continually breathes beneath its own surface. We drift onward, letting this whispering vacuum surround us like warm fog. The idea is gentle and yet enormous, that the emptiest parts of the universe are not empty at all, but overflowing with activity. And it leads to a deeper, more troubling question. If the vacuum is full of energy, then why is there a universe at all? Because, by all calculations, the energy of empty space should be enormous. So enormous that it should tear reality apart. So enormous that galaxies could never form. So enormous that the universe should explode into chaos instantly. And yet, it didn't. The vacuum's energy is real, but it is tiny. Unthinkably tiny. Millions of times smaller than the math suggests. Physicists call this mismatch the worst theoretical prediction in the history of science. It is a soft contradiction, a whisper of something deeply unfinished. Something about reality does not add up. Something fundamental is still hidden. We drift deeper, letting the mystery settle around us like cosmic dust. The next phenomenon we approach is even stranger, something that seems to contradict the most basic idea of identity: quantum indistinguishability. In the macroscopic world, everything is unique. Every rock, every raindrop, every person, every star. But in the quantum world, particles lose their individuality. Electrons are not similar. They are identical, absolutely identical, perfectly identical. If you swap two electrons, the universe does not notice. It cannot notice. There is no way to tell them apart. Not by charge, not by mass, not by spin, not by anything. It is as if nature made one electron and copied it perfectly an infinite number of times. This idea unsettles scientists because it means something profound. Identity itself may not exist at the deepest level of reality. Everything is made from the same repeating pieces, so perfectly repeated that the concept of this one and that one loses meaning. We drift through this strange realization softly, gently, trying to absorb its weight. And then we approach something even deeper, one of the most important discoveries in modern physics: quantum fields. Particles are not tiny points floating in space. They are excitations, ripples, in underlying fields that fill the entire universe. There is an electron field, a photon field, a quark field, a neutrino field, dozens of others. These fields are everywhere, always, even in complete darkness, even in complete stillness. You do not make a particle appear. You excite a field. A gentle vibration in the electron field? That's an electron. A soft ripple in the photon field? That's a particle of light. Every particle that exists is just a pattern, a vibration, a temporary wave in something deeper. And every atom in your body is made of these gentle waves. Every star, every galaxy, every beam of sunlight, every breath. Nothing is solid. Everything is vibration. Everything is resonance. The universe is not built from objects. It is built from waves, from fields, from invisible oceans of energy humming beneath reality. We drift through these fields, feeling their presence not as matter, but as soft, rippling possibilities. And then we reach one more idea, one that feels almost like a dream: that the fields themselves may not be fundamental, that something even deeper lies beneath them. Perhaps the universe is not made of particles, not made of fields, not made of space, not made of time. Perhaps all of these are shadows of something even simpler: patterns, information, relationships, possibility. Physicists do not yet know, but the deeper they look, the more the solid universe dissolves into something soft, mathematical, almost poetic. And as we drift through this quantum ocean, this trembling foundation beneath everything, we are left with a single, quiet truth. Reality is not what it seems. It never was. And the journey into its depths has only just begun. As we drift deeper into the quantum landscape, a new layer of mystery begins to unfold. Quietly, slowly, like a curtain lifting in a dimly lit theater. The further we descend, the more the familiar fabric of reality begins to loosen, thread by thread. What once appeared steady now feels delicate. What once felt definite now shimmers with uncertainty. Tonight, we move toward one of the most haunting ideas in quantum physics. The notion that reality is not only uncertain, not only interconnected, but fundamentally unfinished. We begin with something that feels almost impossible. Particles do not have properties until those properties are measured. Not hidden properties, not unknown properties, but non-existent ones. An electron does not have a position. A photon does not have a path. A particle does not have a spin, not until the universe is forced to choose. We drift deeper into this idea gently, letting the weight of it settle. The world we see, the world of chairs and trees and mountains and stars, feels permanent, defined, stable. But beneath that stability lies a trembling foundation. A foundation in which reality is not built from certainties, but from questions. And those questions only become answers when someone, or something, observes them. This leads us to one of the most delicate, almost dreamlike concepts in all of physics. The quantum wave function. It is not a wave of water, not a wave of sound, not a wave of light. It is a wave of probability. A gentle mathematical ripple that describes everything a particle might be. Every position, every motion, every possibility. Not the particle itself, but the cloud of futures surrounding it. And yet, this cloud collapses instantly the moment a measurement is made. The wave of possibilities freezes. It chooses. It becomes one thing and not another. Hundreds of interpretations try to explain why. None agree. None provide comfort. Every answer feels like a riddle wrapped in a whisper. Some physicists say the wave function is real, an ocean of possibilities that fills the universe. Others insist it is only a tool, useful but not true. Still others argue that everything that can happen does happen, in countless parallel realities layered silently beside our own. We drift gently through these interpretations, like soft paths in a fog. The Copenhagen interpretation: reality forms when observed. Many worlds. Reality branches endlessly like leaves on a cosmic tree. Pilot wave theory: particles are guided by hidden waves, invisible and silent. Relational quantum mechanics: properties only exist in relation to other observers. Objective collapse: reality snaps into form randomly, without being watched. None of these are proven. All of them could be true. All of them could be illusions. The quantum world refuses to reveal its secrets, no matter how softly we ask. We move deeper now, into one of the strangest and most delicate concepts of all: quantum decoherence. It is the gentle process by which the quantum world becomes the classical world. The mechanism through which waves of possibilities crystallize into solid reality. The moment the soft haze of superposition dissolves into a single outcome. It happens constantly, quietly, instantly. Every time a particle interacts with its environment, with light, with air, with heat, with anything at all, its delicate quantum state collapses, not violently, not dramatically, but softly, like a soap bubble touching the surface of water. And with that collapse, reality becomes defined again. A particle that could have been everywhere at once becomes something ordinary. Here, not there. This is why we do not see chairs in superpositions. Why planets do not exist in multiple orbits at once. Why cats are not both alive and dead. Decoherence stabilizes reality. It filters the quantum possibilities into the classical world we recognize. And yet, it does not explain why one outcome happens and not another. It only explains how possibilities fade. The answer to why this choice and not the others remains untouched, a quiet mystery resting at the bottom of everything. We drift toward an even deeper question now, one that has troubled physicists for decades. Does consciousness play a role in quantum collapse? The idea is delicate, controversial, whispered rather than spoken. Some of the greatest physicists in history entertained it, not because they wanted to, but because the mathematics seemed to allow it. The observer effect. Not the human observer, but any interaction that extracts information from the system. Any process that distinguishes what the particle is from what it could be. But some interpretations go further. They suggest that awareness itself may play a role, that consciousness might not sit outside the quantum world, but inside it, intertwined with it, part of its unfolding. This does not mean the mind controls reality. It means reality may not fully exist until information enters awareness. That the universe is not a machine running blindly, but a story unfolding as it is observed. We do not know if this is true. Physicists disagree. Some say the idea is unnecessary. Others say it is unavoidable. A few say it is profound. But none can prove it wrong. We drift deeper into the subtle darkness, letting this possibility linger gently in the air. The idea is not frightening. It is quiet, almost peaceful. The notion that the universe and awareness may be entangled in ways far beyond our understanding. And then, out of this stillness, we encounter another haunting truth. Randomness lies at the heart of reality. Not apparent randomness, not chaotic behavior, but true randomness. Events that have no cause, no reason, no underlying mechanism. The universe sometimes simply chooses. A particle decays. A quantum state collapses. A vacuum fluctuates. A possibility becomes real. For no reason at all. This realization drifts through us like a cold breeze, and yet it brings with it a strange peace. Because randomness means freedom. The universe is not locked, not fixed, not predetermined. It breathes, it wiggles, it improvises. Reality is not carved in stone. Reality is painted in watercolor, soft edges, blended possibilities, ever-shifting shapes. We drift through the final stretch of this quantum landscape, letting its strangeness settle into our thoughts like gentle dust. The further we go, the clearer one truth becomes. The quantum world is not terrifying because it is chaotic. It is terrifying because it is deeper than logic, because it resists being understood, because it refuses to be reduced to simple answers. It is a world made not of objects, but of relationships, not of things, but of patterns, not of certainties, but of shimmering potentials. And here, at this depth, we begin to feel the quiet heartbeat beneath reality. The universe is not built from matter. It is built from mystery, soft, endless, beautiful mystery. And our journey into that mystery continues. As we drift deeper into the quantum underworld, the strangeness does not ease. It grows softer, yes, quieter, more meditative, but also more profound. Here, the boundaries between what is real and what is merely possible continue to blur, dissolving like faint ripples fading into still water. Tonight, we move toward one of the most unsettling quantum ideas of all, the notion that time itself may not behave the way we believe. In the classical world, time moves forward, steady, constant, unwavering. A second is a second. A minute is a minute. The past lies fixed behind us, the future ahead, the present unfolding like a gentle path beneath our feet. But in the quantum world, this path begins to shimmer. Time loses its strict direction. Its rhythm becomes uncertain, elastic, strangely delicate. It stretches and bends around probabilities, as if reality itself has forgotten which way is forward. Physicists discovered something haunting. Quantum events do not always obey the ordinary flow of time. In certain experiments, the choice made in the present appears to influence what happened in the past. Not metaphorically, not symbolically, literally. We drift deeper, letting this idea unfold softly. The delayed choice quantum eraser experiment, one of the most shocking tests ever performed, suggests that information about how a particle behaves can be erased after the particle has already acted. And when the information disappears, the past changes. The particle behaves as if it always knew what we would do, as if the universe is not waiting passively to be observed, but participating in the observation, responding to it, weaving itself around it. This does not mean the future controls the past. It means something more subtle, more delicate. Time, at the quantum level, is not a strict line. It is a web of possibilities, and those possibilities influence one another in ways that defy intuition. The past is not fixed. The future is not empty. Both are connected through the trembling probabilities at the foundation of existence. We drift through this idea like through slow-moving mist. It is not frightening. It is not chaotic. It is strangely calming, like realizing that reality is more fluid than we believed, more flexible, more alive. But we move deeper still. Tonight, we explore another idea that terrifies physicists, not because it is violent, but because it is subtle. Quantum non-locality. The eerie phenomenon in which particles separated by vast distances, meters, kilometers, even thousands of light years, act as if they are still one, still connected, still whole. Change one. The other changes instantly, faster than light, faster than time itself. This is not a metaphor. It is not theory. It is not speculation. It is experiment. Repeated, confirmed, verified. Non-locality is real. It means that the universe does not obey the classical rule that objects must touch or communicate to influence one another. Instead, the universe behaves as if everything is part of a single, unified system. We drift through this truth slowly, letting its weight settle like snow. It means distance is not what we think it is. It means separation is not what it appears to be. It means the universe is not a scattering of isolated parts, but a single, continuous field of connection. Every particle in existence was once compressed into a single point, the primordial seed of the cosmos, and in some quiet, gentle way, they never fully separated. The echoes of their unity still hum beneath reality. We drift further, arriving at one more haunting idea. Quantum states do not merely exist. They coexist. A particle is not in one state. It is in all possible states at once, a gentle, shimmering cloud of overlapping realities. And when the wave function collapses, when one outcome becomes real, the others do not simply disappear. Some interpretations suggest they continue, not in our world, but in others. Parallel branches of reality. Quiet, unobtrusive, layered gently beside our own. The many worlds interpretation. Not a violent splitting, not a chaotic explosion of worlds, but a soft branching, like the growth of a tree. Each leaf a possibility, each branch a timeline, each subtle division a new version of the universe. We drift through this idea like through a quiet dream. It does not matter whether it is true. What matters is that it is possible. And possibility is the true currency of the quantum world. We move deeper still. In this quiet region of the quantum landscape, we encounter one last phenomenon. A soft, almost spiritual concept hidden in the equations. Quantum information cannot be destroyed. Not by heat, not by pressure, not by time, not by black holes. Information is eternal. Even when particles decay, even when stars collapse, even when matter dissolves, the information describing what existed remains encoded in the universe. Nothing is ever truly lost. Not memory, not history, not identity. They may transform. They may scatter. They may refract in impossible ways. But they do not vanish. This idea terrifies physicists, not because it implies destruction, but because it implies permanence. A permanence woven into the soft, trembling fabric of the quantum world. Reality remembers, even when we do not. We drift through this final truth gently, letting it settle in the quiet spaces between thought. If the universe stores every trace of what has happened, then reality is not merely a sequence of events. It is a tapestry, a soft, interconnected web of all that was, all that is, and all that could be. We drift slowly upward through this shimmering world, carrying with us the quiet understanding that the deeper we look into the foundations of reality, the more the universe feels like a question, not an answer. A question woven from possibility, uncertainty, mystery, and soft, trembling wonder. And our journey into that mystery continues. As we drift deeper into the quantum abyss, reality becomes softer, quieter, and far more mysterious than anything the classical world ever suggested. The deeper we go, the more we feel the familiar scaffolding of existence loosening, as though the universe itself is exhaling, allowing us to glimpse what lies beneath the surface of everything we know. Tonight, we enter a new region of quantum strangeness, a place where energy, matter, time, and information melt together in ways that defy logic and yet remain profoundly, hauntingly real. We begin with one of the most delicate concepts in physics: zero-point energy. The lowest possible energy a system can have. Not zero, never zero. A faint, trembling baseline that remains even when everything else has been stripped away. It means that emptiness is never truly empty. Stillness is never truly still. Silence is never truly silent. Even in perfect vacuum, colder than space, quieter than infinity, the quantum fields that form the foundation of reality continue to vibrate softly, like the distant echo of a sound that never fully fades. These vibrations are responsible for some of the most subtle effects in the universe. They tug gently on atoms, shift energy levels, and even push objects apart through what physicists call the Casimir effect. Two uncharged plates placed extremely close in a vacuum will be nudged together or apart because of fluctuations in empty space. In the quietest possible environment, reality still breathes. We drift onward, letting the idea settle softly. The next phenomenon we encounter feels even stranger, almost supernatural in its implications. Quantum teleportation. Not the teleportation of objects, not science fiction beams of matter moving through space, but the teleportation of information. The complete quantum state of one particle transferred to another, instantly, perfectly, without touching, without crossing the distance between them. The original state disappears. A perfect copy emerges elsewhere. No travel occurred, no movement, only pure transfer of quantum identity. This is not theory. This is experiment. Repeated, verified and used in early forms of quantum communication. Teleportation exists, just not in the way we imagined. We drift deeper, feeling the weight of this truth settle like fine dust. And then we reach something even more delicate, something physicists whisper about with fascination and discomfort: quantum error correction. In the classical world, information is fragile. Noise corrupts it, heat destroys it, time erodes it. But in the quantum world, information can be protected through patterns of entanglement, woven into states that cannot be destroyed without unraveling the entire system. It means that information can be hidden, preserved, encoded in the structure of reality itself. Even when particles vanish, even when systems are disrupted, the encoded information can survive, like faint memories woven into the universe. We drift through this realization slowly, letting it resonate in the silent space around us. And now we approach one of the most profound ideas in all of quantum physics, an idea that connects particles, information, and gravity: the holographic principle. The possibility that the entire three-dimensional universe, every star, every galaxy, every atom, every thought, may be encoded on a distant two-dimensional boundary, not metaphorically, literally, like a cosmic hologram projected from a surface beyond our reach. This principle arises not from imagination, but from the mathematics of black holes. Physicists discovered that the information contained inside a black hole, everything it has swallowed, does not scale with the volume inside it, but with the surface area of its event horizon. The skin, not the interior. This was a shock, a contradiction, a soft fracture in our understanding. And then came the haunting realization: this might not apply only to black holes. It might apply to the entire universe. Everything we experience in 3 dimensions may be encoded on a distant cosmic boundary, a vast sheet of information that contains the blueprint of reality. We drift through this idea gently. It does not frighten. It unfolds like soft mathematics whispering through the void. But the quantum world still has deeper mysteries to offer. Tonight, we approach something physicists have struggled with for decades: the measurement problem. Why does observation collapse the wave function? Why does possibility become reality? Why does one outcome emerge instead of another? We do not know. We have guessed. We have argued. We have built interpretations like fragile constellations in the dark. But the truth remains. We are looking into a mirror that refuses to reflect clearly. We drift into the next mystery: quantum vacuum decay. The idea that the universe might not be in its lowest possible energy state, that we live in a metastable quantum vacuum, a false floor floating above a deeper, truer level of reality. If the vacuum were to decay, everything would change instantly. The laws of physics would vanish, particles would dissolve, reality itself would rewrite. Not violently, but smoothly, silently, like a new version of existence sliding over the old. This possibility is not fear. It is humility, the understanding that even the emptiness between galaxies may not be what it seems. We drift deeper. And here, in this quiet corner of the quantum realm, lies one final idea: soft, delicate, and infinitely mysterious. Quantum reality is relational. Nothing exists alone. Nothing exists independently. Nothing exists without interaction. A particle has no properties by itself, only in relation to something else. Information is not absolute, only meaningful when compared. Reality is not made of isolated facts, but of relationships, correlations, entanglements. It means that the universe is not a cold machine, but a web of connections, a web of interactions, a web of meanings woven between particles, fields, and observers. We drift through this understanding slowly. Reality is not a collection of things. Reality is a collection of relationships, gentle, trembling, interdependent. And here, in the soft darkness of the quantum world, one truth becomes clearer than ever. We are part of this web. We are not separate. We are not outside observers. We are threads in the tapestry. And the quantum world, with all its softness, strangeness, and impossible beauty, continues to unfold beneath us, within us, and through us. As we drift even deeper into the quantum foundation of reality, the strange silence around us begins to feel familiar, almost comforting. The world we once believed to be solid, predictable, and mechanical has now dissolved into something softer, gentler, and far more mysterious. And with every layer we uncover, the universe reveals another quiet contradiction, another whisper that challenges everything we think we know. Tonight, we enter a region where the quantum world begins to shape the very structure of space and time. Here, the boundaries between geometry, information, and reality itself start to merge, painting a picture of existence that feels more like a thought than a physical object. We begin with one of the most astonishing discoveries of modern physics. Entanglement is not just a quantum phenomenon. It is the architecture of space-time. For decades, physicists believed that space was a stage, vast, empty, silent, upon which the laws of physics played out. But as we drift deeper into the quantum realm, a new idea emerges. Space-time might come from entanglement, not metaphorically, literally. Connections between quantum particles, these delicate, invisible threads, may weave the fabric of the universe. The more entangled a system is, the smoother and more connected space-time becomes. Remove entanglement, and space itself begins to tear apart. This idea is soft, haunting, and profoundly beautiful. Space is not fundamental. Connection is. We drift deeper, letting this realization settle around us like a warm blanket. The quiet truth beneath reality becomes clearer. The universe is not built from things. It is built from relationships. And entanglement is the glue. We move onward into an even stranger phenomenon. Something that sounds impossible and yet has been confirmed again and again. Particles do not have definite histories. In the quantum world, a particle does not move from point A to point B along a single, fixed path. Instead, it moves along every possible path simultaneously. An infinite number of trajectories woven together into a soft superposition of histories. This idea comes from Feynman's path-integral approach, one of the most powerful and unsettling formulations in physics. To understand how reality unfolds, the universe does not choose a path. It sums over all paths. Every possibility contributes. Every trajectory matters. Reality is not a line. It is a cloud. We drift through this idea slowly, letting its softness settle into the quiet spaces of thought. The present moment is not a single thread pulled taut through time. It is a tapestry woven from every potential route reality could have taken. And with this perspective, we approach another delicate truth. The boundary between the future and the past becomes blurry. In the quantum world, particles do not simply follow equations forward in time. Some of their mathematical descriptions flow backward, not in a paradoxical way, but in a gentle, symmetric way that suggests time itself may be a two-way river at its deepest levels. Not all physicists agree on how to interpret this. Some say it is simply a mathematical tool. Others believe it reveals something profound. Perhaps the universe does not distinguish between past and future the way we do. Perhaps the arrow of time emerges only at large scales, from heat, from entropy, from cosmic drift, and beneath it, time is soft, reversible, and uncertain. We drift deeper, letting this possibility linger. It is not frightening. It is quiet. It is peaceful. The next idea we encounter is one that blends quantum physics with computation. The universe may behave like a quantum computer, not a computer made of hardware and electricity, but a system where information is processed through entanglement, superposition, and interference. Every particle carries bits of information. Every interaction processes that information. Every quantum state evolves as if following a natural algorithm. Not mechanical, not binary, but deeply probabilistic. This viewpoint leads to something even more subtle. Reality may not be built from matter. Reality may be built from information. The physicist John Wheeler expressed this idea with 3 simple words: it from bit. The universe, at its deepest level, is not physical. It is informational. Patterns, encodings, correlations. We drift into this idea like floating into warm fog. It feels soft, but it carries enormous implications. If reality is information, then space, time, matter, energy, all of them are emergent phenomena. Not fundamental, not primary, but expressions of something deeper. Information woven into quantum fields woven into space-time woven into the cosmic tapestry we call the universe. We move onward. Tonight we reach one more delicate quantum truth, an idea so strange, so abstract, and yet so beautiful, that it feels like the whisper of a cosmic dream. Particles do not simply exist in space-time. They help create it. The geometry of the universe is not fixed. It is dynamic. It is responsive. It is woven from the interactions of quantum fields, shaped by the flow of information, smoothed by entanglement, rippling with fluctuations. Space-time is not the stage. It is the performance. We drift through this quiet realization with a sense of deep calm. The more we explore the quantum world, the more we see that the universe is not a machine, not a set of objects, not a frozen landscape of matter. It is a living system, a soft network of relationships, a web of probabilities gently shifting beneath our awareness. And beneath this web lies something even more mysterious. The universe is self-organizing. Without instructions, without supervision, without external laws, the quantum world arranges itself into atoms, atoms into molecules, molecules into stars, stars into galaxies, galaxies into clusters, clusters into cosmic webs. From trembling uncertainty emerges order. From pure probability emerges existence. From quantum softness emerges the entire majestic architecture of the cosmos. And as we drift through this final stretch of the quantum landscape for tonight, one quiet truth becomes undeniable. The universe is not built from cold, inert matter. It is built from connection, from information, from possibility, from soft, trembling quantum threads woven together into something unimaginably beautiful. And our journey continues. As we drift deeper into the quantum foundations of the universe, the silence grows even softer. The world beneath reality no longer feels chaotic or violent. It feels calm, delicate, almost meditative. Yet the ideas that unfold here are among the most unsettling in all of science. Tonight, we enter a region where the quantum world begins to blur into something even stranger. A place where reality itself becomes optional. We begin with one of the most haunting ideas in modern physics. Quantum states are not things. They are stories the universe tells about what could happen. A particle is not a particle. A wave is not a wave. Everything we think exists is only a description of possibilities. When we observe, the universe selects one version of the story. When we do not, it keeps all versions alive. We drift deeper. Physicists call this the problem of interpretation. But the truth is softer than that. It is not that the mathematics is unclear. The equations work perfectly. It is that reality does not behave the way we expect reality to behave. What is a particle? What is a measurement? What is existence? These questions lose their sharpness down here. They flow together like colors in a watercolor painting. And from this softness emerges another idea. The universe is not made of objects. It is made of transitions. Reality is not a thing. It is a process, an unfolding, a becoming, a constant movement from possibility into actuality. But even that description is incomplete. Because quantum physics tells us something even stranger. The universe does not decide everything at once. It decides as late as possible. Events do not crystallize until they must. Outcomes do not emerge until they are forced. The world stays flexible, undefined, open, for as long as it can. This idea becomes clearest through quantum experiments in which choices made after an event influence how that event must have happened. Reality rewrites itself, softly, quietly, without contradiction, because contradiction only exists when time behaves in one direction. And here, the direction of time becomes a soft suggestion rather than a strict rule. We drift deeper into this strange territory. Now we approach an idea that terrifies physicists, not because it is violent, but because it removes the last shred of separation between observer and observed. Quantum contextuality. It means that the result of a measurement depends not just on the system and not just on the observer, but on the context, the entire setup, the choices, the relationships. Reality is not independent. It is relational. Just as a word can change its meaning depending on the sentence, a quantum outcome can change depending on the experiment built around it. Particles do not carry intrinsic properties. They carry potential meanings, meanings that arise from the entire situation in which they appear. This idea dissolves the notion of an isolated universe. Everything depends on everything else. We drift deeper still. Here we encounter one of the most profound realizations in quantum physics. The universe does not store information in space. It stores information in correlation. A particle alone is meaningless. Two particles together form relationships. Many particles weave patterns. Those patterns are the information. Those correlations are reality. We drift through these correlations like through a web of faint, shimmering threads. And from this web, another quiet idea grows. The universe is not random. It is not deterministic. It is something in between, a soft flow of probability merging with delicate mathematical structure, a system that evolves predictably through unpredictable outcomes, a paradox, a harmony, a balance. We move deeper. Now we encounter something physicists discovered only recently, something soft, subtle, and almost poetic: quantum steering. In entangled systems, one particle can influence the probabilities of the other's state simply through choices of measurement. Not force, not communication, just choice. The quantum state of one system can gently guide the possibilities of another, like two dancers connected by a thread of music instead of touch. This idea bends causality, connectivity, locality. It means that in the deepest layer of reality, possibility itself is a shared property. Your choice here changes the shape of possibility there. We drift through this realization like through soft mist. And now, we enter one of the most beautiful and haunting concepts in all of physics. The quantum universe is not built from parts. It is built from wholes. Wholeness comes first. Division comes later. Objects, differences, boundaries, these are emergent illusions. Deep beneath them lies an indivisible unity. A single quantum state that describes the entire universe at once. A single wave function for everything that exists. A single mathematical breath from which all particles, all fields, all interactions arise. This idea is not mystical. It is the natural result of quantum entanglement extended to its limit. The universe is one system, one state, one intertwined structure of endless relationships. And we are threads within it. We drift deeper. At this depth, another idea emerges. A soft, almost philosophical realization. Inside the quantum world, there is no here and there, no this and that, no object and observer. There is only interaction, only correlation, only the flow of information. Space is not where things are. Space is how things relate. Time is not what flows. Time is how change is organized. Matter is not what exists. Matter is what persists long enough for the classical world to notice. Everything else slips softly between states. At this depth, one final truth becomes clear. The quantum world is not terrifying because it defies logic. It is terrifying because it defies separation. There are no isolated things, no disconnected events, no independent objects, no solitary particles. Reality is a web, a whole, a soft, shimmering unity. And as we drift through this unity, calm, quiet, suspended in the most delicate foundation of existence, we begin to understand something profound. The universe is not made of things. It is made of relationships. And relationships are woven from possibility. Soft, trembling possibility. And our journey continues. As we drift into the 9th layer of the quantum world, the silence grows deeper. Not empty, not hollow, but full of something soft, subtle, and almost impossible to name. A presence that feels quieter than darkness and older than time. Tonight, we enter a realm where the quantum world begins to blur into consciousness, perception, and the very meaning of reality. A place where the boundaries between physical law and philosophical truth dissolve. Slowly, like ink spreading through still water. We begin with a gentle but haunting question. If the quantum world does not settle on a single reality until it is observed, what is the role of the observer? To explore this, we drift into one of the most debated ideas in all of science. The observer effect is not simply a disturbance. It is part of the mechanism by which reality becomes real. When we observe a quantum system, we do not merely measure it. We participate in its unfolding. Observation is interaction. Observation is selection. Observation is collaboration between mind and matter. But this truth is too large to grasp all at once. So we drift toward it slowly, gently, letting its meaning unfold like a soft tide. A particle in superposition carries all possibilities. Every path, every state, every outcome. But the moment information becomes available, even if nobody looks, the wave of possibilities collapses. This leads to the first profound idea we explore tonight. Information, not consciousness, collapses the wave function. The universe does not wait for a human mind. It waits for information to exist. Once information is recorded by an atom, a photon, a speck of dust, possibility becomes reality. Consciousness may not cause collapse, but the presence of information does. Yet this raises a deeper question. What counts as information? What counts as measurement? What distinguishes possibility from reality? The answers are not clear. And here, we drift deeper into uncertainty. Next, we approach a subtle idea that physicists whisper about carefully. The universe may be participating in its own observation. Every interaction is a measurement. Every particle is an observer of others. Every exchange of energy is a sharing of information. In this sense, the universe observes itself continuously. It collapses its own wave functions. It defines itself moment by moment through internal interactions. Reality is not waiting for us to look at it. Reality is looking at itself. We drift deeper. Now we enter the delicate region where quantum physics begins to overlap with the mysteries of the mind. Not in the mystical sense, not in the pseudo-scientific sense, but in the purely physical sense. Consciousness is built from quantum processes. Your neurons fire because electrons tunnel, because ions jump across molecular barriers, because quantum potentials shape the flow of signals. Every thought you've ever had is a pattern in a quantum system. Every memory is encoded in a structure whose stability depends on quantum forces. Every emotion, calm, fear, love, is a vibrational pattern in matter made of probabilities. This leads us to a quiet truth. The mind does not exist outside quantum physics. It emerges from it, but we drift deeper still. Now we encounter an idea that is so delicate, so strange, and so rarely spoken aloud that it feels like a whisper hidden inside the equations. If reality is built from information, and if consciousness is built from the processing of information, then the line between observer and observed becomes very thin. The quantum world does not draw a sharp boundary between them. We do. In the quantum realm, there is no hard line between self and world, between thought and matter, between perception and event. Everything is interaction. Everything is relationship. Everything is correlation. And now, from this soft understanding, another idea emerges, an idea that physicists reluctantly admit is possible. Reality may be participatory. Not because the mind controls matter, not because thought shapes the universe, but because reality, at its foundation, is unfinished until information is exchanged. We drift deeper. Tonight we approach one of the quietest and most unsettling truths in quantum theory. There is no single objective reality. There are only consistent shared realities. Quantum experiments performed in recent years, including the Wigner's friend scenario, suggest that different observers can experience different outcomes that are both correct within their own reference frames. This means reality is not singular. Reality is relational. Reality is frame-dependent. There may be no global viewpoint from which the entire universe looks the same. Each observer sees a consistent world, but those worlds may not be identical. This idea dissolves the classical picture of the universe entirely. We drift deeper still, and now we reach one final idea for tonight. A soft, haunting realization that lies at the edge of physics and philosophy. The universe may be fundamentally unknowable, not because it is hiding from us, not because our tools are limited, but because reality itself is woven from uncertainty. The more precisely we try to understand the foundations of existence, the more those foundations slip away. Not like a puzzle refusing to be solved, but like a wave refusing to be frozen. The quantum world does not want to be definite. It wants to be possible. And in this shimmering possibility, in this trembling ocean of maybes, lies the quiet beauty of the universe. It is not a machine. It is not a book. It is not a deterministic script. It is a question, An open-ended question that unfolds through us, within us, and beyond us. And as we drift upward from this deep layer of quantum mystery, one final truth follows us like a soft shadow. Reality is not made of answers. It is made of possibilities, and our journey into those possibilities continues. As we drift into the 10th layer of the quantum world, something begins to change in the silence around us. The strangeness no longer feels foreign. The impossibility no longer feels threatening. Instead, everything begins to merge into a calm, soft understanding. As if the deeper we go, the more the universe reveals that it has always been this way. Tonight, we enter a region where the quantum world begins to touch the cosmic world, where the smallest scales of existence whisper secrets about the largest structures in the universe, where the rules that govern atoms begin to shape the fate of galaxies. We begin with a delicate, haunting idea. Quantum uncertainty creates stability. It seems impossible. We expect uncertainty to ruin things, to create chaos, to break order. But in the foundations of reality, the opposite is true. The Heisenberg uncertainty principle, the idea that we cannot know a particle's position and momentum at the same time, is not a limitation. It is a protection. Without uncertainty, electrons would crash into atomic nuclei. Atoms would collapse. Matter would implode. Stars could not shine. Chemistry could not exist. Life would be impossible. Uncertainty gives the universe room to breathe. We drift deeper. Now we approach one of the quietest and most misunderstood truths. Quantum mechanics is the reason the sun shines. Not fusion, not heat, not gravity, quantum tunneling. Inside the sun, protons do not have enough classical energy to fuse. They should repel each other forever. But the quantum world allows them to slip through their barriers, not by force, not by speed, but by possibility. Every ray of sunlight that has ever touched your skin is a quantum event. We drift slowly through this realization, letting it warm the darkness around us. Next, we approach something even more delicate. Vacuum fluctuations shape the universe. These tiny ripples, these ghost-like bursts of virtual particles, were present in the earliest moments of the universe. And because the early universe was so small, so sensitive, so soft, these fluctuations left imprints, tiny variations in density that later grew into galaxies, clusters, superclusters, and cosmic webs. The largest structures in the universe were shaped by quantum tremors smaller than atoms. From uncertainty came structure. From fluctuation came formation. From trembling came galaxies. We drift deeper still. Now we encounter the quiet truth that unifies the microscopic and the cosmic. Gravity and quantum mechanics do not yet agree. Einstein's general relativity describes planets, black holes, and the shape of space-time with perfect elegance. Quantum mechanics describes atoms, particles, and fields with unmatched precision. But when we try to combine them, when we try to describe quantum particles inside black holes or the first instant after the Big Bang, the mathematics breaks. Two masterpieces of physics, both correct, both incompatible. This is why the quest for a quantum theory of gravity continues. String theory, loop quantum gravity, causal sets, emergent spacetime, holographic dualities, all of them whisper the same soft truth. Reality may be far simpler than either theory alone. We drift onward. Now we reach a region where the quantum world begins to shape the structure of space-time itself. Here, we encounter a stunning realization. Black holes are quantum objects. Not classical monsters swallowing everything, not cosmic abysses, not points of finality. They are quantum systems with temperature, entropy, information, and rich internal structure. Hawking radiation, the evaporation of black holes, is a quantum process, a gentle glow that leaks from the edge of space-time. But this glow reveals a paradox. If black holes evaporate, what happens to the information inside them? Information cannot be destroyed. But if a black hole disappears, where does the information go? This leads to the quiet, terrifying mystery known as the black hole information paradox. For decades, physicists believed that information falling into a black hole was lost forever. But quantum theory says that nothing, not even information, can be erased. This contradiction shook theoretical physics for half a century. Finally, a new idea emerged. Soft, strange, and deeply beautiful. The information does not vanish. It becomes encoded in the structure of space-time. The shape of the event horizon, the entanglement of outgoing radiation, the quantum correlations in the vacuum. Information spreads, it diffuses, it hides, but it does not die. Reality remembers everything. We drift deeper. Now we approach another delicate truth. Space-time may not be continuous. At quantum scales, space may come in discrete units, tiny grains like pixels. Time may tick in quantum intervals, not smoothly, not infinitely divisible, but in soft, indivisible quanta. The universe may be digital at its deepest level, not a machine, but a computation, a process. And now, we reach the final realization for tonight. Gentle, quiet, infinitely mysterious. Reality may not be fundamental. Reality may be emergent. Not built from particles, not built from fields, not built from forces, but built from information, patterns, correlations, entanglement, structure. In this view, space-time is a story the universe tells when enough quantum information weaves together. Matter is the memory of quantum excitations. Forces are relationships between fields. Particles are vibrations in soft mathematical fabric. The universe is not a solid thing. It is a flowing tapestry, woven from the quiet whispers of quantum possibility. As we drift upward from the 10th layer, one truth follows us like a soft echo. The universe is not built from certainty. It is built from potential. And our descent into that potential continues. As we drift into the 11th layer of the quantum world, the silence around us changes again. It becomes deeper, calmer, almost sacred, like standing at the edge of something ancient and infinitely patient. Here, the quantum world begins to reveal its most elusive truths, the ones that hide not in equations or experiments, but in the quiet logic that shapes reality itself. Tonight, we enter a realm where the foundations of existence begin to blur into pure abstraction, where mathematics becomes the language of being, where reality stops behaving like a physical system and starts behaving like an idea. We begin with one of the most delicate concepts in quantum physics. Symmetry is the blueprint of reality, not symmetry in the visual sense, not shapes mirroring each other or patterns repeating, but mathematical symmetry. Rules that stay the same even when the universe is transformed. Rotate it, shift it, boost it, mirror it, warp it through time. If the equations remain unchanged, a symmetry exists, and from these symmetries, the laws of physics emerge. Conservation of energy, a symmetry in time. Conservation of momentum, a symmetry in space. Conservation of charge, a symmetry in quantum phase. The universe is not governed by laws. The universe is the laws, and those laws arise from deep, silent symmetries woven into the fabric of existence. We drift deeper. Now we approach something even more subtle. Particles are the shapes of symmetries. In quantum field theory, particles are not objects. They are representations, manifestations, of deep mathematical symmetries in the underlying fields. Photons exist because electromagnetism has a gauge symmetry. Gluons exist because the strong force has a more complex symmetry. Electrons, quarks, neutrinos, all are ripples shaped by symmetry. This means something profound. Matter is not fundamental. Matter is what symmetry looks like when it vibrates. We drift slowly through this realization, letting it wash over us like a soft tide. Next, we approach another truth, stranger, quieter, and almost poetic. Broken symmetry creates diversity. In the early universe, everything was perfectly symmetrical. Forces were unified. Particles were indistinguishable. There were no differences, no boundaries, no distinctions. Then, as the universe cooled, symmetry shattered. This shattering did not destroy order. It created it. Like ice crystallizing from water, the breaking of symmetry produced new structures, new rules, new particles, new possibilities. Every atom, every star, every galaxy, every breath you have ever taken is the result of a broken symmetry. The universe is not built from perfection. It is built from the gentle fracture of perfection. We drift deeper still. Tonight, we encounter one of the most mysterious ideas in all of quantum theory. Reality may be built from higher dimensional symmetries we cannot see. String theory, M theory, and other quantum gravity frameworks propose that the universe has more dimensions than the four we experience. These dimensions are hidden, compact, curled into tiny geometric shapes. Shapes that determine the behaviors of particles, the strengths of forces, the structure of space-time. We do not see these dimensions, but we feel their influence in every interaction. Like wind-shaping sand dunes, invisible symmetries shape the visible world. We drift through this idea gently. It expands reality without overwhelming it. A reminder that the universe is always deeper, always softer, always more subtle than it appears. Now we reach something even more delicate. A truth that connects quantum physics to the core of mathematics itself. Reality may be made of pure information, and that information may be organized by symmetry. In deep quantum theory, information is not stored in particles. It is stored in relationships, patterns, invariants, transformations. These patterns behave like mathematical objects. They follow rules, they form structures, they weave reality. This leads to a quiet, astonishing idea. The universe behaves like a mathematical object because it may be a mathematical object. We drift deeper. Now we enter a region where physics begins to touch the edge of philosophy. Is the universe discovered or invented? Does it exist independently, or is it a self-consistent mathematical structure? Max Tegmark's mathematical universe hypothesis suggests that the physical world is simply one mathematical structure among many. A coherent, self-consistent pattern that exists because its logic holds. Whether or not this is true, the quantum world behaves as though mathematics is not a language describing reality, but the substance from which reality is built. We move deeper still. Tonight, we encounter one more subtle and haunting concept. Dualities. In modern physics, dualities reveal that two seemingly different theories can describe the same underlying reality. Space versus time. Particles versus waves. Strong versus weak force. Gravity versus quantum mechanics. Strings versus particles. Fields versus geometry. Dualities whisper a quiet truth. Reality is not what it appears to be. There are no fundamental descriptions, only different perspectives on the same deeper structure. We drift through this idea softly. It dissolves rigidity. It invites openness. It hints that the universe is not limited to a single viewpoint. And now, as we reach the end of this layer, one final truth emerges. Gentle, paradoxical, and endlessly beautiful. The deeper we go into the quantum world, the more reality becomes about relationships, not objects. Matter is relationship. Space is relationship. Time is relationship. Energy is relationship. Information is relationship. Symmetry is relationship. Everything we call real exists only through its connection to everything else. The universe is not a collection of things. It is a geometry of interactions, a tapestry of symmetries, a quiet, trembling network of possibilities woven into existence. And as we drift upward from the 11th layer, this soft truth follows us like a calm whisper. Reality is not made of matter. Reality is made of meaning. And our journey into that meaning continues. As we drift into the 12th layer of the quantum world, the silence grows vast, not empty, never empty, but spacious, like a cathedral carved from pure possibility. Here, the quantum world stops feeling like a set of rules or equations. It begins to feel like a landscape, soft, shimmering, immeasurable. Tonight, we enter a region where the quantum world brushes against the edge of the infinite, where physics does not merely describe reality, but hints at what reality could be if the universe were allowed to express its full mathematical depth. We begin with one of the most delicate concepts in quantum theory. A quantum state is not a thing. It is a space of all possible things. A wave function is not a description of what is. It is a description of what may be. A map of possibilities. A cloud of futures. A shimmering blueprint from which the universe chooses reality. But here, in this deeper quantum layer, something changes. The wave function may describe not just particles, but entire universes. The Wheeler-DeWitt equation, the foundation of quantum gravity, suggests that the universe itself has a wave function, a quantum state describing every possible cosmic history. Every geometry, every timeline, every birth and death of stars, every pattern of galaxies, every version of reality. We drift gently into this idea. It is too large to hold tightly. We must hold it softly. Now we approach a truth that unsettles even the most confident physicists. At the deepest level, the universe has no time. Time does not appear in the Wheeler-DeWitt equation. Not past, not future, not flow. The fundamental laws of the universe are timeless, frozen, eternal. So why do we experience time? Because consciousness moves through the wave function like a beam of light scanning across a page. Time is not a river we float down. Time is the order in which we access the information of reality. A sequence, a structure, a soft illusion generated by the way observers traverse possibility. We drift deeper. Next, we reach an idea that sounds impossible, but emerges naturally from quantum gravity. Space is not continuous. It is quantized. At the smallest scales, space comes in discrete units, tiny loops, grains, or networks depending on the theory. They are unimaginably small, but not zero. Space has a texture, a quiet structure, a quantum fabric, and this fabric behaves like a living thing. It stretches, it vibrates, it fluctuates, it rearranges itself, it evolves. This leads us to a breathtaking realization. Space is not a backdrop. It is a product, a consequence of deeper quantum information. We drift through that understanding like through a soft current. Now we approach something even more delicate. Something that has only begun to reveal itself over the past 2 decades. Space-time may emerge from entanglement networks. Not particles, not fields, not geometry, but entanglement. When entanglement increases, space becomes smoother. When entanglement breaks, space tears. Black holes are dense knots of entanglement. Wormholes may be geometric reflections of entangled systems. The expansion of the universe may be the unfolding of quantum information. This idea carries profound beauty. Space-time is woven from relationships. We drift deeper still. Tonight, we arrive at one of the most mysterious edges of quantum theory. The quantum world calculates everything that could happen, but it reveals only what must happen. This leads to a soft paradox. If all possibilities exist in the wave function, do they all become real? Many worlds' interpretation says yes. Other interpretations say no. Some say reality is simply the branch you experience. Others say all branches exist mathematically, but not physically. The truth is unknown and perhaps unknowable. We drift gently through this uncertainty. Now we approach an idea that connects the quantum world to logic, to computation, to mathematics itself. The universe processes information. Quantum mechanics is the operating system. Reality evolves because information evolves. Quantum states update. Probabilities shift. Entanglement rewires itself. Fields adjust their configurations. The cosmic wave function flows forward through possibility. This leads to a quiet, profound realization. The universe may not be made of information. It may be information. Energy is information. Matter is information. Space is information. Time is information. The laws of physics are simply the rules that govern how information transforms. We drift into this idea like into warm fog, not to solve it, but to feel its shape. Now we arrive at one of the most beautiful concepts in physics. Emergence, the idea that simple quantum rules, silent, tiny, and local, can give rise to the vast complexity of the cosmos. From simple rules come atoms. From atoms come chemistry. From chemistry comes life. From life comes awareness. From awareness comes meaning. The universe is not mechanical. It is layered. It is emergent. It is self-organizing. And this leads to the final, haunting truth of this layer. The quantum world does not define reality. It generates reality. Reality is a process, a story, a continuous unfolding from possibility into experience. And as we drift upward from the 12th layer, one calm truth lingers. The universe is not a place. It is a becoming, and our journey into that becoming continues. As we drift into the 13th and final layer of the quantum world, the silence around us feels different, deeper, wider, almost infinite. It is the kind of silence that does not erase sound, but contains it. A silence so complete that every truth we have uncovered seems to echo softly within it. Here, at this final depth, the quantum world is no longer something beneath reality. It is reality. Unfiltered, unmasked, revealed in its purest and most delicate form. Tonight, we explore the final mysteries, the ones that sit at the boundary between physics, philosophy, and the very meaning of existence. We begin with one of the softest and most haunting truths. Quantum reality is not local. Quantum reality is not objective. Quantum reality is not definite. The universe is not what it seems, not because it hides from us, but because it exceeds our ways of seeing. It is too wide to collapse into a single picture, too deep to fit inside one interpretation, too connected to allow separation. As we drift deeper into this realization, one idea emerges with astonishing clarity. Reality is built from relationships, not things. This truth follows us through every quantum phenomenon. Entanglement, connection without distance. Superposition, being without being singular. Contextuality, meaning without intrinsic properties. Wave function collapse, reality unfolding through interaction. These are not quirks. They are messages. They are the signatures of a universe in which separation is an illusion and unity is the foundation. We drift gently into the next idea. The universe is not a collection of events. It is a single, continuous process. A wave function evolving, a computation unfolding, a cosmic story told through probability. Nothing is static, nothing is final. Nothing simply is. Everything is becoming. We move deeper. Now we arrive at a truth that physicists rarely say aloud, but increasingly accept. The classical world, the world we see, touch, and live in, is not the real world. It is an approximation, a simplification, a useful illusion. Atoms are not solid. Particles are not particles. Space is not smooth. Time is not fundamental. The macroscopic world is a shadow cast by the quantum world, a world of pure possibility. We drift further. Now we reach a question whispered in theoretical physics rooms around the world. If reality is built from information and relationships, what is the role of the observer? Are we just passive witnesses? Or are we active participants? Threads woven into the cosmic fabric? The answer that emerges from the deepest quantum layers is delicate. We are part of the equation, not separate from it. Our bodies are quantum systems. Our thoughts are quantum patterns. Our choices, our perceptions, our awareness are woven into the web of interactions that define reality moment by moment. This does not mean we create the universe with our minds. It means the universe includes us in its unfolding. It evolves through us just as we evolve through it. We drift on. Now we reach one of the most profound quantum ideas, a truth that dissolves the boundary between physics and meaning. The universe is self-interpreting. There is no outside observer, no external reference frame, no higher vantage point. The universe looks at itself through particles, through fields, through stars, through consciousness. You are not an outsider looking in. You are an expression of the universe looking at itself. We drift deeper into this realization, letting it warm the silence. And now, as we approach the final edge of the quantum world, we reach one last truth. Soft, simple, overwhelming. The universe is not a thing. It is an experience. It is not an object to be measured, but a story to be lived. Not a machine, but a process. Not a structure, but a flow. A flow of information, a flow of possibilities, a flow of meaning. And every moment, every breath, every photon, every interaction, every quiet thought before sleep is part of that flow. As we drift gently upward from the 13th layer, carrying everything we have learned with us, one final whisper follows like a soft echo. Reality is not made of certainty. Reality is made of wonder. And that wonder, quiet, shimmering, infinite, is the true heart of the quantum world. Our journey ends here, but the mystery continues. Always, everywhere, within everything, and within you.